Factoring, the sum or difference of cubes, or SOPPS as I like to call it. I had a teacher in high school, and she was one of my favorite teachers of all time, and she used SOPPS. So how do we identify when to factor using SOPPS? Well, two terms, and there can't be a GCF. So it's got to be two terms, and you always check for a GCF first. So once you've taken a GCF out with two terms, it's got to be two terms. All the coefficients and constants are perfect cubes. That's the thing times the variable, or the thing by itself without a variable. Okay, and all the powers are multiples of 3. That just makes it easy. You don't have to worry about rational exponents or radicals or any of that kind of stuff going on here. So your perfect cubes up to 12 cubed are listed here, okay? Just to let you have 1, 2, 3, 4, like 4 cubed is 64, 8 cubed is 512, 12 cubed is 1728, right? 11 cubed is 1331. Just to let you see some of these, just look at that, take a picture of it if you want to. I'm about to turn the page, but take your phone, take a picture of it, and that way you have those readily available. You may know them by heart. If you don't, that's fine. But you need to be familiar with them so that if you see 343, you go, oh, wait a minute. That's 7 cubed. Maybe this is SOPPS. So here, x cubed plus 8, let's factor it. Well, we have what? We have two terms with no GCF, right? So let's look at it and see, how do we factor this? How many terms? 2. Okay? Perfect cubes. Yep. Right? 8's a perfect cube. 8 is 2 cubed, and then the one's in front of the other one. Is the power a multiple of 3? Well, 3 is a multiple of 3, right? And then there's no GCF, okay? Since this meets the criteria we established, it is SOPPS, all right? So how do we factor using SOPPS? The factored form will contain 2 sets of parentheses. The first set of parentheses will contain 2 terms. This is the setup. Okay, and the second set of parentheses will contain 3 terms. This is where to apply SOPPS. So let me just give you a little background about the setup here. I actually teach setup SOPPS. My teacher in high school did SOPPS, and we all picked it up and we did fine. And whenever I first started teaching over 2 decades ago, I was so excited to go teach SOPPS, and I ran in my college algebra classroom and I started teaching it at this university, and boom, 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 I'm just hitting it, and my students forgot to set it up on the test. They couldn't do SOPPS because they didn't set it up. So after a few years of banging my head against the wall saying, why don't y'all get SOPPS? I realized, hey, maybe I should tell them to set it up and that kind of thing. So I added setup to my SOPPS. And so that's sort of what's going on here. We set it up and then we apply SOPPS. So I teach setup SOPPS. So the first parenthesis, 2 terms, is a setup. It's very much like your difference of squares setup, and then you apply SOPPS to the setup. To construct the first set of parentheses, we set up SOPPS. First, we take the cube root of any coefficient or constant, and we divide the power exponent of any variable by 3 in the first term of the original expression, and we place the result in the first term of the setup. So here, what we've done is I've taken this x cubed, and I've divided the power by 3 and given it x, okay? So there's your setup, the first term. Then the next part of the setup is we place the sign of the second term from your original expression. My original expression is plus. We're going to put a plus right here. That's what this is telling me. Okay? That's what that's telling me there. So let's go through here and do that. All right? There's my plus. Then we come through and say, okay, what do we cube? What do we cube? Lastly, take the cube root of any number here. So take the cube root of that and put it here. What's the cube root of 8? It's 2, right? So if we go there, then boom, plus 2. So we set it up by taking the powers and divide by 3, keep the sign the same, and then take the cube root of the number or power divided by 3, depending on what's there. Each term is possible to have a number, a coefficient out front, or just a constant, and a variable to a power. So that's why I put those in there and said do each thing, all right? So we don't worry about the sign of the second term because we've already taken into account what that is by bringing it down in the step before. All right, so there is our setup, and we'll set it up the same way each time. Now we are ready to move on to the second set of parentheses and apply SOPPS. And remember, it's going to have 3 terms. So here I have my SOPPS written here, okay, for SOPPS. The first S means to means to square. Square opposite product plus the square. That's what SOPPS is. Okay, so let's fill in SOPPS one letter at a time. So we're going to square with the S. So what we do is we take the first term from the setup. We're going to take this. We're going to square it and put it right there. Okay? We're going to square it and put it right there. So let's see what that looks like. X squared is x squared, right? We take this term and square it, and we get that right there. All right. So then the next thing is opposite. So remember in our setup, we took this sign here and we put it exactly there. Now we squared this. Now we're going to take this and take the opposite sign and put it right there. So if there's a plus there, we're going to use a what? A minus, okay? And then if there's a minus, put a plus. So these two signs are always opposite. These two are always the same. And then the opposite there for that one, okay? It's always the same in the setup, and then you change it for the first sign you write down in your SOPPS. Now look, we just took care of the sign of the next thing. So when I get to product means multiply. I'm going to multiply the two terms in your setup, but I'm going to disregard the sign. So I'm going to take just the x and the 2. I'm not worried about that sign because I already put a sign there, okay? I know that a positive x times a positive 2 is positive 2x, but we put the opposite sign. Then we just multiply them irregardless of the sign. Even if there was a minus, we multiply them without worrying about the sign. So 2 times x is all we worry about. We don't worry about the sign right here at all. 2 times x is 2x, okay? And that's where we get that middle term there, that product. Then always a plus. Always. Always, this is always a plus no matter what. And then finally, we square again. We're going to square the last term in the setup. And the last term is 2. And what is 2 squared? It's 4, okay? So then x plus 2 times x squared minus 2x plus 4 is our factored form of x cubed plus 8. And if you wanted to, you could take the x and distribute it to all 3 and this to all 3. And what's going to happen is everything's going to cancel out but the first and the last term, okay? So the final factored form of x cubed plus 8 is x plus 2 times x squared minus 2x plus 4. SOPPS works whether you have the sum of 2 cubes or whether you have a difference here. You might have a minus there of 2 cubes. It still works. Because of that opposite sign business, SOPPS, one word, set up SOPPS, S-O-P-P-S, works for both plus and minus. Every book I've ever taught out of for 2+ decades now, and even for probably close to 8 or 9 years before that, I tutored algebra ever since I took it in high school. I started tutoring people in it. And for almost 30 years now, every book I've ever seen gives 2 formulas for this. Okay? And that's why I like SOPPS so much, because it covers both formulas. I don't teach a lot of formulas in class unless I have to. I don't even write these formulas down. I just do SOPPS. So if you want to do formulas, that's fine. But formulas are typically for people who are more advanced or they already understand it. And if you already understand it, you're probably not in this class anyway. You're probably taking something else. So hopefully SOPPS helps out some. So let's work some of these. Factor completely. How many terms is this? 1 term, 2 terms. Any GCF here? And this is a little different, but 27 and 125, if we kind of go through the list, there's nothing in common with either one of those. So there's no GCF. So now what do you cube to get, or take the cube root of 27? So what I'm going to do is come down here and I'm going to do set up. And then over here I'm going to do SOPPS. Okay? My setup is going to be 3x. The cube root of 27 is 3. And then take 1/3 of the power here. 1/3 of 3, divide the power by 3 is 1. So then that's 3x. Then what do? We bring down our sign. So that minus sign just simply comes down right here. And then what do you cube to get 125? Or what is the cube root of 125? It's 5. Okay? So that becomes 5. Then I'm ready to do my SOPPS. And the way that I write this down, I like to show this way. I like to go 3x in parentheses squared. Because what happens is I have a ton of students who will write 3x squared with no parentheses. They forgot to square the 3. You with me? You got to square both the number, the coefficient, and the variable. That's why I put it in parentheses there, so you get 9x squared. So don't write 9x or don't write 3x squared. You got to have 9x squared. That's the only correct answer for this here. Then the opposite sign, the opposite of negative is what? Positive. So then that's opposite minus positive. And then product, you're going to multiply these together. 3x times 5, and some of y'all are screaming at the computer, Mr. Guest, it's a -5. Remember, we already took care of the sign. I know it's a -5, but here in SOPPS, we forget about the sign because the O told us what sign to put. The opposite, we already took care of it. All right? So then 3x times 5 is 15x. And then what does this second P stand for? It's always a what? Always a plus sign. Always. Doesn't matter what the original problem is. Doesn't matter what. It's always a plus. And then S means to square the last thing, and that's a 5. And again, I've already taken care of you can put the negative here. Negative number squared is still positive, but we already took care of it because it's a plus. So then 5 squared is 25. So this last part of this, the second parenthesis here is 9x squared plus 15x plus 25. The setup is 3x minus 5. And so then here we have our final answer. And if you did everything else first, if you did if you did GCF and difference of squares, those are the only two other ways to factor with two terms, okay, that you learn in college algebra typically. So I want to put that disclaimer there in case there's something else you learn somewhere else along the way further in math. But typically in a college algebra 2 course in high school, algebra whatever, you do factoring with two terms. It's either GCF, difference of squares, and now SOPPS, sum or difference of cubes. Okay? Your teacher, unless your teacher knows SOPPS, they probably call it sum or difference of cubes. That's why I titled the video that and make that the way, but it's SOPPS. That's what I do. So let's look at this one. How many terms? Two terms, right? Is there a GCF? No. Are all my coefficients and constants cubes? Well, 64 is 4 cubed. What about 1? Is that a perfect cube? It is. Sometimes we go, oh, no, it's not. But what is 1 times 1 times 1? It's 1. That's right. So it is a perfect cube. And then my powers are multiples of 3. In fact, they're exactly 3. So here we're going to have my setup. And then we're going to come over here and have SOPPS. Okay? So setup SOPPS. So my setup is going to be 4, right? 4 cubed is 64. Cube root of 64 is 4. And then X and Y. And then plus, we bring the sign down. And then 1 cubed is 1. Or the cube root of 1 is 1. However you want to think about that. All right? So 4xy plus 1. Then we square the first term, the whole thing, the 4, the x, and the y. So 4 squared is 16. X squared and y squared. You got to square it all. If it's one term in parentheses squared, you got to apply that squared to each one of those things, each one of those factors, the 4, the x, and the y. Then the opposite sign, we have a plus, becomes a minus. The product is 4xy times what? 1. Remember, we don't care about plus or minus 1 there because we already took care of my sign. So 4xy times 1 is 4xy. Always a plus. That's what the P stands for, always a plus. And then square, let's see. Square the 1. Well, that's hard. What is 1 squared? 1. And again, if you've done your GCF and your difference of squares before the SOPPS, then when you get SOPPS done, you're done. It won't go any further. So 4xy plus 1, and then 16x squared y squared minus 4xy plus 1. All right? So remember, as you watch my videos, if I'm moving a little fast for you, just pause it, copy stuff down, process it for a second, then unpause it, rewind it, whatever you need to do. Okay? So let's look at the next one here. 8m cubed minus 27n cubed. All right, so minus, it doesn't matter. Plus or minus, sum or difference, doesn't matter. It's two terms, no GCF. It's not a difference of squares either. It's SOPPS because 8 and 27 are perfect cubes, and then the powers are multiples of 3. So then we need to do my setup. And then come over here, SOPPS. Okay? So setup is going to be what? What is the cube root of 8? It's 2. And then m, divide that power by 3, minus. This time we bring the minus sign down. Whatever the sign is in the problem is the same sign in the setup. And then what's the cube root of 27? It's 3. And then n. So then we're going to square 2m and square it. And that's going to be what? That's not 8. Squared is going to be 4m squared. That way when we take 4m squared times 2m, we get what? 8m to the third. That's why we did that. And then the opposite sign. What is the opposite of a minus? Plus. Then product is 2m times 3n. And that's going to be what? 6mn. And then always a plus. Always a plus. And then square the last term. 3n squared is going to be what? 9n squared. You got to square the 3 and the n, the variable. Okay? So 9n squared. So 2m minus 3n, and then 4m squared plus 6mn plus 9n squared. All right, so let's look at another one. And here, I'm trying to go a little crazy on you and give you some crazy stuff. 216 c to the 9th minus 125 d to the 6th. If you go back and look at the table I gave you, if you took a picture of it or just rewind the video back to that table, if you're not familiar, this is 6 cubed and that's 5 cubed. So the cube root is 6 and 5 of those two. And these two powers are multiples of 3. There's no GCF here. There's no GCF, and it's not difference of squares. So let's go through here and do the setup. And then SOPPS. So the setup is going to be 6c to the third. Right, 9 divided by 3 is 3 for the power. We divide the power by 3, take a third of the power. And then 6 times 6 times 6 is 216, so the cube root of 216 is 6. Minus, we bring the minus down, cube root of 125 is 5. And then d what? That's right, squared. 6 divided by 3 is 2, so d squared. Now we apply SOPPS. So we're going to take the 6c to the third and square it. So this one's a little more advanced, right? But we take the 6 and square it and get 36. And then what do we have whenever we take c to the third square? We have a power to a power. We multiply the exponents and get c to the what? 6th power. What is the opposite sign here? That's right, plus. Then we take 6c to the third and we product. We multiply it with 5d squared. And again, I know this is negative, but we already took care of that with the opposite, right? So we don't worry about the signs. We just say 6c cubed and 5d squared. And that cubed is pretty ugly here. This is a 3, okay? So that's going to be 6 times 5 is 30. And then we have c to the third, d squared, and then always a plus. Always a plus. And then we square 5d squared. We square it. So 5 squared is 25. And then d squared squared, we multiply those 2's and get d to the fourth. So 25d to the fourth for that second s in SOPPS, okay? And I didn't mean to make this look like it was raised to a power there. I was going to try to move it, but I don't think it's going to work. So that s there, that's 5d squared squared. So then, I just moved some stuff around. Hang on. All right, there we go. Sorry, moved that around by accident. So let's look here. We have 6c to the third minus 5d squared. That's our setup. Times our SOPPS parenthesis is 36c to the sixth plus 30c to the third, d to the second, plus 25d to the fourth power. And there I go again. Got chosen the wrong thing down there. Here we go. Here we go. Let's box this in. There's our final answer right there. All right. So let's see what we have waiting for us on the next screen here. 8 minus 343w to the third power. So it's two terms, no GCF, and it's not difference of squares. 8 is 2 cubed, so the cube root of 8 is 2, and the cube root of 343 is 7. Okay? So this is SOPPS again because also the w is to the third power. Now look, don't get caught up and go, oh, the w is last. It's not SOPPS. Yeah, it is. Okay? Yeah, it is. All right? So then 2, and don't put the w up here. The w is at the back. Put the w here in the back. Okay? 2, and then minus. Bring the sign down. We said that was 7w. 2 minus 7w. Now we go to SOPPS. We're going to square the 2. That's just forced. We don't have a variable there. So don't force it. Don't make anything be there that's not there. Okay? So opposite sign, minus is a plus, right? Changes from minus to plus. Product. We're going to take the 2 and multiply it by the what? 7w. And again, I know the 7w is negative, but we already took care of the sign when we're doing SOPPS. Typically, I'm harping at you about keep the sign, keep the sign. You got to make sure you pay attention to the sign. We already took care of the sign with SOPPS, so here we don't worry about the negative. It's just 2 times 7w is 14w, always a plus, and then 7w squared, right? The second term is 49. 7 squared is 49, and then w squared. W squared. So then that's going to be 2 minus 7w, and then 4 plus 14w plus 49w squared. All right. Now the one thing I want to say is this answer is fine for me in my class. Okay. I don't even care. I've taught out of books, many of them actually, most of them probably, who said, hey, be sure and put your answer in descending order. Listen, if you're watching my video somewhere else and I'm not your teacher, if your teacher wants it in descending order, then by all means write 49w squared plus 14w plus 4 in the second parentheses, and in the first one put negative 7w plus 2. Right? The signs stay the same. It just looks funny. Negative 7w plus 2 looks different, but it's the same thing. So if your teacher, your instructor, your professor wants you to write it in descending order, then you do that. Or if you're working on an online platform like My Math Lab or something like that, Hawks, whatever, then put it in descending order if it asks for it. Right? If you're certain you got it right and you're putting it in this form, look at the instructions and see, oh, descending order, that's all I'm doing wrong. Right? Sometimes that frustrates us as students, right? We go in there and we get it right. We think we got it right and it just keeps telling us we're wrong, and we get another problem, we still do the same thing, and It's because we didn't read directions. Teachers do it too. Don't let us tell. Don't let your teacher tell you. We do it too. Okay. So confession time there. We do it too. All right. So what about this one? Let's look here at this one and see what we have. We have 250x to the fifth plus 16 x squared y to the third. Do I have a GCF here? I sure do. Both these numbers are even, so at least a 2 will come out. So let's start with that. 2. And then both terms have x in them, and the lowest power of x is x squared. So if I take a 2x squared out, right, and both of them don't have a y. What is 250 divided by 2? 125. And then if I took 2 of my x's out, that's x to the third. Plus, if I take 2 out of 16 and get 8, I took my x squared out, so I don't have any x's in this term. I'm left with y to the third. If I look at this now, I ask myself, is it SOPPS? Well, I've done the GCF. Is it difference of squares? No. Is it SOPPS? Yes. That's 5 and 2. The powers are multiples of 3. So it works out. So what I'm going to do is I'm going to leave my 2x squared out front. And then I'm going to come down here and do my 2 parentheses. And I'm going to do my setup first. Always do it first. And then SOPPS. Okay? So on my setup here, what is the cube root of 125? It's 5. And then x to the first power, bring down the plus. Always bring down the sign here, right? And then what is the cube root of 8? It's 2. And then y, take the 1/3 of the powers, or divide the power by 3. 3 divided by 3 is 1. So the setup is 5x plus 2y. But don't forget, you already took the 2x squared out front. It's got to stay there. It's part of your answer. It's okay that you brought it out as a GCF. You can mix up any ways to factor. You can do a GCF and then bottoms up, or GCF and then list method, or GCF and then difference of squares, or in this case, difference SOPPS. So then you square. You're going to say 5x and square. It's going to be 25x squared. The opposite sign, you have a plus, it's going to be a minus. And then the product is going to be 5x times what? 2y, which is 10xy. And then always a plus. Then you take your 2y and you square it for the last s. That's going to be 4y squared. 4y squared. All right? 4y squared. So 2x squared and then 5x plus 2y and 25x squared minus 10xy plus 4y squared. And that is your final answer. And that also concludes our SOPPS, or sum or difference of cubes, video. All right, I hope this helps. Hope it helps you factor and do well in your algebra class wherever you may be.